objective again is going to be to talk about rational exponents. And you guys already hit it on the money. Rational means what again? Fractional, right? So some of you said put it into a ratio. Great. So maybe I want you to write fractional. So I am going to show you that you actually already know how to do today. You haven't seen it this way before. All right, and how I'm going to show you this is what we have done before. Cube roots of a to the 6. How have we dealt with that before? Yes, good. Now, I know that this reduces. I'm not going to reduce it right now. What I want you to do is I want you to look up there. You see how in the denominator, there's the index? So right now, this is a fractional exponent, yes? So right now, you also see that it says to me that this is the cube root just by looking at the denominator. Yes. All right, so the numeric format of this is going to say nth root of a to the m is equal to a to the m divided by n. And n is our root. And a lot of times when I read to myself, when I read those fractional exponents, I don't read it as, let me put an example up here. I don't read it to myself as 9 to the 1/2. I say to myself, this is the square root of 9. That's what I say to myself. Let's also look at that inside the root, because there's an invisible index of 2 and an invisible exponent of 1 right there. Think how it's 9 to the 1/2 as well? All right, so what is the square root of 9? 3. So when we read these, you might want to try to read them not as the exponent of what it is asking of you. So this does say 64 to the 1/3, but I'm asking for what root? Cube root. That's right. What is the cube root of 64? 4. And that is our answer. Done. What if I have popped an opposite? What would your answer be? Another one? $7,776 raised to the 1/5. And how else are we saying this to ourselves? It's what root? Fifth root. And fifth root is always special. Fifth root ends in that last digit. So what is the answer? Fifth. Best number ever. I do like that number a whole lot too. Okay, number 3. Let's bump this up just a notch. This time I also put a numerator. So 16 to the 3/4. So we are going to do it in 2 steps. We are still going to do the root first. And then we are going to get the root. So what is the 4th root? In the mind for the 4th root. 4th root is 16. 2. Okay, so this becomes 2. Drag that exponent over cube. And 2 cubes is just over there. 4. Number 4. What if I did, let's do same problem, but this time I'm going to take it to negative. Doesn't mean that our answer should be negative. Yes, the 3 for that's 3. The 5 answer will go to the bottom. The negative says whatever your answer is, take the numerator and put the move down there. The answer is sum that up. 4 9 to negative 5. Last thing we can do first. What is probably my recommendation? Deal with negative x. So we're going to do the 4 9. Let's put in 4. Now 9 fourths is raised to the positive 5 halves. And instead of saying the positive 5 halves, I am saying what type of root is described. Square root. Okay, 1 third 9. 3, 1 third 4. 2, and now we're going to both places this. Alright, so 3 to 6. 2, 4, 3, 4. So 2 to 6. All that works, exponents. We're sliding right through this. Okay, what if I have 1 all over 81 to the negative 3 halves? Where does that negative exponent carry? On the top. Instead of moving it to the negative 3 halves, which root is something exponent? Square root. What is the square root of 81? 9. First, let me flip it. The square root is 9. Now let's cube it. Okay. And 9 cubed, so we give it 729. Right. Before we go to the next one, let me start to show you some reminders. If I say a cubed times a squared, you will tell me the sign there is. A to the 5th, you add them together. If I say a squared over a to the 5th, what are you going to do with this one? Subtract from this one. The bottom, because he is bigger. If I have a squared and I raise it to 4, what is the rule? Parentheses mean not really the reason why. I don't remember that as well. But I think I'm still. Alright, here we go, number 7. So now we have that. The cool thing about this, let me say one more thing actually before we go on. Now, if I have to do the square root of 2 times the cube root of 2, before were we able to multiply those together? No, we weren't able to do anything. We couldn't simplify it. But now looking at those, numbers up there. 2, 1, and 1 right there. I can also write the same problem as 2 to the 1/2 times 2 to the 1/3. Now this is the same as the first numerator over here. We're just going to add together. We need common denominators. So we're going to do 2, 6 and 2, 6 to make 5, 6. And that is our answer. So that's a nicer answer. This is leaving it like this before. I think we'll test this. I don't think it's necessary right now. I'm going to ask for it. Okay, now I'm going to work. X to the 1/6 divided by x to the 5/6. Okay, how again? So what do we do there? So minus 1/6. Ooh, common denominators are really nice. 5, 6, take away 1, 6 is how many 6? 4, 6. Ooh, 4, 6. Reduce it to what? Number 9. What if I had x to the 3/2 raised to 6? What is the rule? What is the rule? Oh, multiply. Okay. 3/2 times 6. So 3 plus top divide. Or are there any shortcuts? Yeah, well, check here, yeah. Alright, 3 goes to 6 how many times? 3, and 3 times 3 is 9. Good. Okay, I think you guys are ready to try it. Yeah? Yeah. What's that? Yes, that's it. So here we go. 25 over m to the 4th raised to the negative 1/2. How many of you are dealing with the negative exponent first? A little bit of a head start before we go through all together. So you guys should do split first and make it a positive 1/2. Okay, so instead of saying 1/2 this time, it's learn what root am I asking for? The square root. So we can either take the square root of x to the 4th, or we can just say 4 times 1/2 is just 2. So, and the square root is 25? 5. Right, one more time. More challenge. X to the 2/5 over x to the 1/5, all raised to the negative 8. What is the times? How many of you flipped there? How many of you are reducing right now? Okay. How many of you are reducing? So a lot of you should be good first. Yeah. Then you said you could reduce. Just give me some pictures. Keep it there. From the bottom. Keep this taking me 1 second. How many of okay. Really hard one. What's 1 to the 8? 1. Okay, and then multiply the 8 to the 1/5. X to the 8 is correct. And then you're done. Alright, so a couple things I want you to write down before we are done, so you know kind of what your goal is. If your base is a number, like 16 to the 5/4, your goal is to simplify it down to a single number. You know, sometimes it's not possible. Like if I sent 5 to the 1/4, do you know the 4th root of 5? No, that's done. He's done. Can this one go farther? Yes. Okay, so Mr. Smarr, what is the 4th root of 16? 4 root of 2. 2 is the 33. Okay, so we got done with one number and that's if you have variables, if your base is a variable or variables, your goal is to take it down to one variable, one exponent for every variable. So if I have an x and a y in the problem, I don't have to get it. So your goal is to simplify and get one exponent for every variable. Kind of like we did for number 11 right here. So 2 variables in here. So we have 1, we snap them together, right? And give a final exponent to our answer. That's our goal. And your homework this evening is going to be section 8.7, 2 through 26 even, 72, 74, and 76. Now, 72, you will need graph paper. Probably just a mini graph is all you need, just one. So if you guys want to grab a mini graph, go for it. You guys know where those are, so take them with you. And 74 and 76, these are systems. Or no, these are quadratics that you do factor. Remember, the factoring list is on my webpage. I'm sorry, you were not dismissed.